Greetings, fellow nerds. You've seen me use molecular sieves in previous videos to dry solvents and assist in water removal for some reactions. They're not too expensive, but they're not cheap either. So I was perusing eBay for molecular sieves and I found a supplier in China at a price that was too good to be true. It's almost certainly a fake, but I was too curious to pass it up. So I bought some to run some tests. I'm also going to use some of my authentic lab-grade molecular sieves to compare them to. First, we heat the sieves for several hours at 200 Celsius to drive off any water and activate them for use. I didn't weigh them first, but you can if you want to check if there's a change in mass. They should get lighter as they lose water. If they start gaining mass, then they're oxidizing and they're definitely fake. Once you're done, turn off the heating and let them cool. I also ran the same activation procedure with the lab-grade molecular sieves. Now for the actual testing. Place some in a vial with a thermometer. Through the magic of video editing, I'm going to compare them side by side. Now just add some water to each. I'm adding until it just reaches the top. If these are molecular sieves, then there should be a temperature spike as they absorb water. This happens because molecular sieves are engineered zeolite materials that are extremely porous and thus have extremely high surface area. Water can squeeze into the pores and absorb onto the internal surface. In doing so, they release heat from van der Waals forces. The effect is very small, but because molecular sieves have extremely high surface area, it adds up to a noticeable spike. And there we go. You can see the temperature spike for authentic molecular sieves is quite large. We've jumped 46 degrees Celsius from the starting temperature of 24 degrees to 70. 70 degrees Celsius is actually hot enough to burn you. Now your results may vary depending on the size and quantity of the molecular sieves you're using. Now, the Chinese molecular sieves are interesting in that they are spiking, but the increase is rather low. Starting from 28 Celsius, we're only jumping up 18 degrees to 46. Now granted, this is very crude and not a very scientific test, especially since I'm not using a proper calorimeter, matched masses, or even exactly the same amounts of water. But this spike is too weak to attribute to external variables alone. These molecular sieves just aren't very good at absorbing water. But they are not fake as I originally thought. The fact that there is a temperature spike does prove there is some reaction with water. I'm pleasantly surprised they work at all considering how little I paid for them. Anyway, so that was the water test. The higher the temperature spike, the better the molecular sieves. Okay, let me switch out with some dry sieves again and run a different test. This time I'm adding in methanol. Now both sieves are supposed to be type 3A, meaning they have pore sizes 3 angstroms in size. Water is about 3 angstroms in size and thus easily fits in the pores and gets absorbed. Methanol is about 4 angstroms in size, so it shouldn't be absorbed. This test is thus specific for molecular sieves type 3A. Looking at the authentic molecular sieves on the left, we can see no temperature spike. The methanol isn't being absorbed at all. To be honest, this lack of change is a little too good. I've done this test many times before with various high-grade sieves, and usually I see a tiny jump of 1 or 2 degrees. Maybe my methanol is slightly cooler and absorbing the excess heat. Nonetheless, this shows the authentic sieves to be high grade because they almost completely block methanol and don't absorb it. The smaller the temperature spike, the better, the opposite of the water test. The Chinese molecular sieves are a different story. They are rising slightly in temperature from 24 degrees Celsius to 34 degrees Celsius, or about a 10-degree difference. Not as much as water, but far greater than the authentic molecular sieves. This proves the pores are not all 3 angstroms in size. A significant percentage is larger and able to absorb methanol and release heat. Whatever chemical process the Chinese manufacturers use, it produces sieves of low quality with higher pore size variability than the authentic molecular sieves. Nonetheless, overall, these eBay molecular sieves exceeded my expectations, primarily because I had none to begin with. If I had no access to high-quality molecular sieves, I'd probably use these. Maybe use a lot more to compensate for the lower quality. Now, before everyone goes all anti-China, keep in mind some of these high-grade molecular sieves are also made in China, but the companies that make them don't sell on eBay and don't sell cheap. Instead, they sell to other industries or chemical supply companies. So it's really a matter of finding the right supply chain for your purpose. Anyway, that's how you can test the quality of your molecular sieves. The water test that gives higher temperature spikes the higher the grade is and works for all sieve types, and the methanol test specific for type 3A molecular sieves that gives lower temperature spikes depending on the grade and how specific the pores are just for water and not methanol. Thanks for watching! Special thank you to all of my supporters on Patreon for making these science videos possible with their donations and their direction. If you're not currently a patron but would like to support the continued production of science videos like this one, then check out my Patreon page here or in the video description. I really appreciate any and all support.